All right, thank you, Ron. And very nice to be here. I really appreciate the opportunity, and it looks like a great turnout. So this is great to see. I'm going to be focusing on the Google Smart Analytics solution. So if you tuned in yesterday for the AI and ML, I'm going to kind of expand this or augment that conversation with the Smart Analytics solution. And there's actually some overlap that I'll talk about. A little intro. So I'm Dan Zaratsian. I'm an AI and ML specialist with Google. And really, so my focus is to work with customers across industries to build out AI and machine learning solutions. And it really focuses on, building the model, like training the model, deploying the model. But there's so much else around it that I'm going to cover here that's important, from databases, from the orchestration engine, from connecting to different sources and providing that integration. So we'll dive into it and we'll touch on different areas of the Google platform that helps facilitate some of that. If we look across the analytics platform, now it's a simplified view, but there's quite a bit going on here. But the truth is there's many components that really make up an analytics platform. And I think you've probably seen this a lot in different like data science life cycles or analytics life cycles or whatever it's called. There's always kind of the data ingest piece, starting from left and going to right. And as part of that cycle, we go into the process, store, analyze, and then kind of report or provide additional intelligence on top. Now, from a Google perspective, the data ingest of a smart analytics platform encompasses tools that support point and click data transfer. So we have our data transfer service for loading data into Google Cloud Storage. We have a transfer service for BigQuery to actually load data from relational style databases into BigQuery, which I'll get into more, but it's our data warehouse, our relational serverless data warehouse. And then there's also several components, and this is just a highlight of a couple of them, but that support real-time streaming applications. So maybe something like PubSub that facilitates a data ingest point for real-time events and payloads, or something like Cloud IoT that'll let you connect to IoT devices and then transfer those, edge communication or edge events into PubSub and then ultimately into the cloud. And it facilitates this bidirectional communication to where if you need to send signals back to edge devices, you can do that. You can also push some of the TensorFlow ML models back to the edge. So there's a lot going on here that we could dissect. I won't go through all of these, but as you think of a platform, I think that it's important, especially if your teams are starting to build out this capability, or you're looking for best practices around how do I stitch everything together to actually build an analytics platform within our team or organization. I think it's important to touch on all of these, and you don't have to include all these services, certainly, but in some case you're going to need some sort of capability to ingest data, and it might be from multiple sources, so that's why you would use different tools. You're going to need to do some sort of processing, and this could be real-time in-stream processing, or it could be, batch type processing after the data lands within, raw data storage like cloud storage, or even something like BigQuery. You're going to need a place to land the data for, storage, but then also something that enables analytics on top of that, and even machine learning if that's the use case of what you're trying to build out. Underlying all of that are tools that also kind of stitch this together. So many of you may have used different vendors for doing this. One of the things that Google has that's a great tool for data ingest and even some ETL type processing is called Cloud Data Fusion. So it takes care of integration to different sources, even other clouds, even other relational databases, ingest that data, perform some transformations to it, and then loads it into the cloud storage within Google in this case that you want as your final landing zone. And then the other two that I think are incredibly important, and I'm actually seeing a ton of traction. So as I mentioned, I focus a lot on the machine learning side, but data catalog and just one of the pain points I think for organizations is to really understand what kind of data they have, where that data lives, and what are some of the key metrics that they want to monitor around that data. For example, does that data contain PII? Does it, when's the last time it's been updated? Are there changes to the schema? Are there, like, does someone have access to that data set that they shouldn't, or that shouldn't? Or has the number increased substantially that we want to flag it to where there's too many people that have access to it? There's all kinds of different situations and scenarios depending on your use case and what kind of data you're protecting. But data catalog is one of those tools that is really powerful in doing some of that data inventory management, and then even firing off triggers to say, hey, this data has PII, let's scan it and maybe redact the information. For example, that's just one flow that could be fired off. And then the last thing that's also really beneficial as part of a smart analytics platform is some orchestration engine. So as you're going from start to finish, typically you want to automate these things. It's perfectly fine. In fact, I usually encourage manual type of stepping through the process, especially when getting started, to figuring out what works, what kind of variables we need to set, like how these services interact with each other. But ultimately, we find that whether you're talking about an analytics solution, a machine learning solution, or just an application in general, having some sort of orchestration engine, in this case, Cloud Composer, which is built on Apache Airflow, that's one option for kind of saying, hey, once this data lands in cloud storage, I want to pick it up, I want to do these transformations, I want to land it in BigQuery, then I want to fire off some SQL queries to do additional transformations. Then I want to land that table, and once that table's in the landing zone, then I want to build a machine learning model against that table that was just created. And then once the model finishes, I want to promote that to an API endpoint so that my application can consume the model results. I was kind of just walking through a little scenario there. Certainly there could be a lot of different design patterns, but that's something that an orchestration engine such as Composer can help you with. Okay. Now, I guess the way that I think about this, and I wanted to put the slide in here because as you think of, you've heard lots of great presentations here today, and maybe even throughout the week if you've been listening in multiple days. One of the things that you probably see, and a trend that I see at Google and I've seen across the industry, is that depending on the skill set of your team, the needs of your applications that you're building, and even your internal structure, you're gonna need a tool that kind of meets the demand for those different skill sets and different teams. And when I'm speaking to different teams about analytics or machine learning, many of them can fall into one of these three categories. Sometimes the business steps in and does some of this work. Sometimes there's no data scientist and there's only like developers building the product. Sometimes there's a fully mature data science team. So really depending on where you are in the journey and what your team looks like, there needs to be really high-powered, customized capabilities to build and train machine learning models and analytic solutions using code and deploy those. We believe there needs to be like a low-code or no-code option here in the middle for people that either need to get things done really fast, maybe aren't super strong programmers, but really understand the statistics and what goes into an analytics pipeline. That's kind of what this middle group's for. And then there might also be the need to just have analytical tools and orchestration components and data catalog and other things that are available to your data developers, or not data developers, but just developers in general. So that they can interact with that platform using the programming language that they prefer, or if they want a UI, but typically using the programming language that they prefer, and also just calling through REST or Java or Python the different endpoints to trigger orchestration, to fire off machine learning models and get some of the results back based on pre-trained machine learning models, for example. So I typically like, if you think about an architecture and a flow, this is a little bit generic, but I find that it fits a lot of use cases, at least to start, and then we can kind of dissect this depending on business needs and what the data looks like and things like that. But if we kind of look at this architecture, typically organizations have data that's coming in. So it might be database records, it might be logs, CSV, JSON, some data that's coming in, and you want to process it in the cloud. You want to do something with it. Build out reports, do visualizations, build a machine learning model on it, whatever. So data comes in, it goes into BigQuery as the data warehouse, and then from there you can layer on data visualization and reporting tools. Very simple flow. It's perfectly fine actually to start here, and some teams do. Now, as you think about, well, what else can I do with this architecture? Well, typically the way we do this in cloud is you would set up an architecture to where you have a like blob storage or like raw landing zone. Some people, you can call this a data lake, you can call this a landing zone, object storage, whatever you want to call this, but basically the best practice is to kind of bring that data in, load it in cloud storage, and then from there, BigQuery can pick that up, process the data as needed, whether it's a materialized or native table that you create within BigQuery, or you maybe layer on an external table that just simply points to the data that's in cloud storage. Okay, that's a decent start, and then gets a little bit more complex. What happens if you have an existing database that you want to migrate to the cloud or even integrate with? So in the case of like MySQL, Postgres, maybe you want to use a cloud native service that supports that. It could be a little bit more tricky, like if you have a Mongo database, then you can actually leverage that within the cloud as well and integrate based on some tools that we have within our marketplace to support MongoDB, for example. It also is something that you'll see, and something that we see all the time, are hybrid cloud solutions. So having the capability in the case of BigQuery Omni to actually go out and query across other clouds based on a familiar SQL syntax. So that's another part of the architecture that you may include. Now, again, just to reiterate, this is I'm throwing different scenarios at you all. Like, it doesn't have to be all of this, but these are kind of some of the things that we think about as we build out the architectures. Another thing, if we back up and say, well, once we have the data into BigQuery, you might have a team of analysts or data scientists that want to start to do, just explore the data, write some code against it, maybe build models written in Python or whatever language you're using. So we can layer on our AI notebooks, which is part of our Vertex AI platform, and that can facilitate that. And I can get into much more if anyone has questions about that. Feel free to post those or shoot me an email afterwards, and I can respond with some of that. But with Vertex, that gets super deep, and that's the conversation or the presentation I gave yesterday. But if you want to get advanced, there are very sophisticated capabilities within our Vertex AI platform that supports TensorFlow, PyTorch, and scikit-learn, some others, as well as AutoML capabilities. So if you want, and I'll touch on this in a little bit, I touched on it a bit yesterday, but AutoML is also a low-code or no-code type option for building machine learning models based on a variety of data sources that you're looking at. The Smart Analytics platform might also incorporate Hadoop or Spark type jobs. So this is especially true. I wouldn't say so much. I'm not seeing too many net new use cases with Hadoop and Spark, but It's incredibly powerful. I wrote a lot of Spark code in my career, and I'll tell you that a lot of organizations, especially that have a lot of really good code written and assets around that data, and even have quite a bit of large data that they need to manage within Hadoop, this is where something like maybe Google's Dataproc could come in, to where you can land that data, whether it's in JSON or Parquet or whatever the format, and then leverage Spark and the Hadoop style infrastructure to query that data. Okay. There's AutoML. I kind of already talked about that, codeless UI. And then, that's the kind of up top was mostly batch type of streaming that I was generalizing the architecture for. But we also know that there's the need for real-time streaming data ingest. In that case, data might come in. These might be real-time logs as well. This might be sensor events. This might be a variety of things that you're trying to ingest in real time and then process. So this would typically look something like loading into Cloud PubSub, which is our async messaging service. Similar to, some of you may have used Kafka. We also support Kafka as part of our marketplace. Cloud PubSub is our native globally scalable messaging service. So that's something that we would ingest data into PubSub. It would then go into Cloud Dataflow, which is built on Apache Beam. So you write open source code and we scale it up for you within something that's called Cloud Dataflow. And then that could land the results in BigQuery or maybe Bigtable if you want some NoSQL style layout similar to HBase or Cassandra if you've used that before. And then on top of that, again, layer on the reports, do whatever you need. Now, I kind of touched on a lot within that architecture. That might seem like a lot, but I think that's a nice design pattern to think through as you're architecting your use case, but also putting together all the different cloud services that you hear from Google. And even if you think broadly of just a lot of the folks that you heard today on giving the presentations, you can kind of think about it where you have to stitch together many of these products in a similar way. Just to back up a little bit and point out the fact that, and you'll see this across many vendors, you'll see this across many clouds, there are a variety of databases that are used for different purposes. And we kind of put some things in here for saying, hey, this database is good for this, and here's kind of like a use case around it. I'll say that one of the things that is heavily used within Google, it's immediately a best practice without knowing much about the use case, is cloud storage and BigQuery are heavily used. BigQuery being our enterprise data warehouse for relational and even nested style like NoSQL type data structures. But then if you look across this, depending on your use case, there are low latency type applications. There are databases that support your existing MySQL or Postgres environment. There are persistent disk. There are globally scalable, fully ACID compliant, databases like Cloud Spanner. So just so you know, there's quite a bit in the portfolio, but this is kind of a cheat sheet. And we also have some other decision trees on our website that help you figure that out if you're just starting the journey on Google and want to figure out what database would be optimal for a use case. All right, I want to talk a little bit more about BigQuery, just because, as I said, it's kind of central to a lot of use cases. So it is our enterprise data warehouse. It supports petabyte scale storage, petabyte scale queries. We've seen pretty significant queries, even from our organizations that are really stress testing it, and even internally, or at least I'll speak for myself, I'm pretty amazed at the performance, both in the speed and in the size that it's able to handle. And we're talking petabyte scale. It's very impressive. The nice thing about it is there's no infrastructure to manage. There's no servers that you scale up or scale down. There's no configuration settings that you have to say, hey, I need this much capacity. You just load your data into the database, and it's fully serverless. It'll scale up and scale down based on the storage that you load into BigQuery, based on the compute or the queries that you execute. And it also supports real-time streaming inserts. So if you do have an application where you need to stream data into BigQuery, it supports both batch, like bulk uploads or loads into the database, as well as event by event streams if needed. I'll say one of the things I really love, especially coming from the machine learning side, is BigQuery supports, it has built-in ML, which is, I can't be certain, but I think it's one of the first that I've seen within SQL style databases, certainly the first and the best that I've seen at this scale. And so it's BigQuery ML is what it's called, BQML. And there's multiple things about that I think are really interesting. I'm going to get to that in the next slide, but first, I think going back to just the core premise of BigQuery and why it's like where it comes into play for your use case or why you might be interested in it is that there are many integrations that we have just built into BigQuery or the BigQuery transfer service, but also, so those are some of the things that are listed here on the left-hand side. But I think probably more importantly, this federated query across multiple sources really helps to put BigQuery as a centralized service within your architecture. But let's say you have data that's sitting out like sheets, Google Sheets data, like Excel style layout of data. Or let's say that you have data sitting in cloud storage or in Cloud SQL or Bigtable as a NoSQL structure, or even across the other clouds through BigQuery Omni, and even for some of these guys, just through BigQuery in general, you're able to execute federated queries to where you can write one query or multiple queries if you choose, but they can all pull in data and consolidate it across multiple data sources that are listed over here on the right-hand side, as well as ingest sources from many sources on the left-hand side. So a nice, easy way to get data into the environment and get off and running, building your models. Now, coming back to BigQuery ML, I think that, again, I feel like this is a really neat thing. And where this comes into play, especially for teams that might not have data scientists or teams that are just really strapped on like cranking out many models and they can't rely on their data science team because maybe the data science team is too busy, maybe there's just too much to do, and so time is an important factor here. And also skill is an important factor in this. So BigQuery ML allows folks on your team or users in general to write SQL code that trains and deploys a machine learning model. And there are many models that we support as part of BigQuery ML. Some of those are listed here. This is just a short list, and we continually add to them at a pretty aggressive rate as far as what's supported. But let's say you want to build a regression model, or you want to do some clustering against your data, or you want to build a recommendation engine, do some forecasting, even deploy, let's say someone on your team built this amazing TensorFlow model, but you want to run it against the billions of records that are sitting in BigQuery. Well, if you didn't have BigQuery, what you would have to do is you might have to create a dedicated environment where you have to like suck out that data and push it across the model, or you have to do some sort of like processing outside of the database itself. What's nice about BigQuery ML is that the data lives in BigQuery, and so does the compute. So because of the compute and the data living together, it's able to execute much more efficiently, and that's kind of where you get the speed from model training and also from model deployment. So if you have to take that model and then create a score of recommendations against billions of records that you have, it's going to be very efficient because it's all right there, all right in BigQuery. No need to move data around to different environments for model scoring or for model training or deployment. And if that's not clear, let me just give a little example here. So what I'm showing is on the left-hand side, we have code that it'll take and it'll actually train a model. And if for anyone that knows SQL, this is pretty standard SQL. In fact, right here is the SQL code that, or the SQL syntax that you would know. Basically, select some variables from my data set. That's standard SQL. That's like SQL 101 for anyone. What's a little bit different is this syntax up here, which is a very small set of parameters, but you say create or replace model, and you give your model a name. You set some options, and within the options, you might say, hey, I want to build a gradient boosting model or a logistic regression model. And depending on what model you have, you can also set a number of parameters that you want to define as part of your model. It might be the learning rate, it might be warm start, a couple others that you see. And this varies depending on the type of model you have. Is it a regression model? Is it a classification model? Is it a clustering, unsupervised model? Then you can you have different parameters depending on what the model type is. And then you can also say what's your target? What are you trying to predict? So in this case, the model is trying to predict a bad accident, a 1 or 0, and then based on like where that accident occurred or where someone is, like what zip code, what vehicle type, etc. We're trying to predict bad accident. And so now if you execute that code, it'll go off, it'll run in BigQuery, it'll train your model, it'll come back, it'll save your model as a model object within BigQuery. And then if you want to take and make predictions using that model that you just built, then you can say select star from, and you just say ml.predict, and you call that model. So this was the model name that we created in the previous slide. And then you just say select star from, like, these are this is the data that you're passing into your model that you want it to be scored. And you run that and you'll get the predictions. So it's very simple. I think it's really great, especially for teams that have really strong analytics and SQL skills, which I see a lot of in organizations, and I think it's awesome. In fact, those teams are usually pretty big and pretty mature and sophisticated. And I think that's less so. Maybe it's starting to pick up a little more, but the people that really know a lot of deep like Python and want to dive down into TensorFlow and really dig into hyperparameter tuning and all kinds of other stuff, if you don't have those people, you don't have enough, this is a really great solution. So, I wanted to just point that out. There's a lot. If you look at the analytics platform, there's quite a bit going on here. And so there's multiple things across our platform. Too much to dig into today, but I want to just kind of put the slide here for awareness. Now, the last thing I want to point out here, I'm going to jump forward, is we have I kind of already touched on AutoML. Let me skip that for a moment. AutoML, again, it's going to handle a lot of the things that happen. It's going to be your low code or no code environment for training models. So I'm skipping that because I already kind of jumped ahead. This is a good one to just put up though real quick when it comes to AutoML, is that it'll handle a lot of the feature engineering for you. Now, feature engineering is incredibly important in data science and in the analytics, and it'll do the standard things that you need to do. So it'll handle one-hot encoding, it'll handle date feature engineering, it'll handle some cardinality in the data and stuff like that. Then it kind of AutoML will also run a model tournament in which it will try and select the best model based on the type of model you're building and the type of outcome that you want from a model accuracy standpoint. And then it'll promote that to production as an API. So that's the short on AutoML. We can definitely get into it quite a bit more. The last thing I want to cover, and then I'll just finish up here in a couple minutes, is Cloud Fusion is one of these data integration tools that I think is very important. And so what it does is it tries to create, it's a UI, a drop and drag UI that allows you to build end-to-end data ingestion pipelines with monitoring. So if something, so we're ingesting some data from Oracle or Netezza into Google Cloud, we can set up those pipes, we can fire them off based on schedules or triggers. That'll come in, we can monitor the flow. Is it successful? Does it fail? Do we need to issue a retry, or is there something else going on? Any sort of data processing as part of that, even integrated security for data at rest and data in motion type security is all handled for you with Data Fusion. And it really takes care of quite a bit of these steps. Now I think there's more that's going to need to happen once data is loaded into BigQuery, most likely, especially from an analytics perspective. But from an ETL type process, Cloud Data Fusion is something that's a really nice addition to a smart analytics platform. And here's just what this looks like. If you're wondering, it's all drop and drag. So you kind of select, hey, where's my source coming from? I can do group bys in here. I can send the data to PubSub. I can send it to BigQuery. I can do joins. I can do this Wrangler task actually connects out to another tool called it's another data processing tool that essentially allows you to structure your data and perform different data quality checks. So that's something that I think is really nice and a nice part to include as part of the pipeline. You don't have to, depending on if you want some sort of intermediate data processing, you can certainly do that. And yeah, anyway, I guess the last thing is you can inspect the data as it goes through these different paths. So if you want to, write some custom Python code, you can do that. You can see the outcome. It'll be flagged as green on successful, or if it's running, it'll be red if there's a failure or some sort of alert. So, just something to keep in mind. I think I've talked a little bit about high-level architectures, some tools to use, BigQuery as the database, Cloud Fusion as this ETL data ingest pipeline. So, hopefully you all got something out of that. There's quite a bit that was covered there, but such as analytics platforms and the needs around it, and it really varies by organization and by team. So I want to just thank Ron and the Angelbeat team for hosting us and for putting on this great conference. So thank you, Ron, and back to you now.